what makes GCQ is distinct from what is available on the market is really the parameterized GCQ query language syntax. And this is our focus today. I will start with very baby step and start with like a hello world in GCQ. So the first query I'm going to talk about is named hello, and its function is returning the one-hop neighbors of a given person. So the syntax is very simple. You just do it like PL/SQL in Oracle or SQL procedure in Microsoft SQL Server. So you can say create a query, and then you name the query, and then you have the parameters, person. And there are many types in the parameters, and one of the basic type is the vertex type, and then a parameter name, and then you specify which graph this query is designed for. And then this query body is a sequence of query blocks, and we use a single SQL blocks to traverse the graph, and each SQL block will generate a vertex set. We give name for each vertex set. For example, there are 2 query blocks in this hello query. A seeding block, start equals to P. A seeding block is basically assign parameter to some other set to the vertex set variable. And then there's a one-hop edge block. And the one-hop edge block will generate a vertex set named result. And like I said, the seeding blocks just assign the input parameter to the start vertex set name. And the one-hop edge block is borrowing the select from where construct from the relational SQL syntax. However, the from clause in the GCQ is not a table. It is an edge pattern. The edge pattern is a triplet. It always starts from a vertex set. And the middle part is one or multiple edge type and constrain the edge pattern. And the rightmost part is one or more vertex type, constrain the target vertex types. Then this triplet essentially specify an edge pattern that we want to find those instances that matching this pattern in the graph database. For all the 3 parts of an edge pattern, we can add an alias by a colon and alias name. And if you're not familiar with the alias concept, you can think of it as a variable name bind to the corresponding part of the triplet. So here I bind the source to the start vertex set. I bind the alias name E to the middle part of the edge type, and I bind the target alias to the target vertex set. And the benefits of introducing alias is I can use this alias anywhere in the select query block, such as the where clause or the accum clause and the order by or limit. And all these expression places, I can use the alias as a shorthand to refer to the corresponding part in the triplet pattern. Finally, the edge block can select either the source or the target vertex set. Because as I said, each building block in this query body is a vertex set. And the right-hand side of an equal sign will produce a vertex set and assign to the vertex set name on the left-hand side. The last statement is the print statement. So you can print a vertex set or a list of expressions. In summary, you can see this single hello query will return the one-hop neighbors of a given input person P. And after we write this simple query, we will call the install query and the query name to install this query to generate machine code. And then at the same time, it will generate the REST endpoints. So you can treat it as a service, treat this query as a service and supply different parameters to invoke this service. So let's try some queries. So I will first see who are the, how many one-hop neighbors does Tom have? So I invoke this query in the GCQ shell. Okay, so it returns some JSON results. So the first few lines is the metadata. So the query is not in error, and there's no comments for this query. And the version of the social schema is version 1, and API of this JSON is version 2. And then it's a result object. So there are 2 person Tom's first hop neighbors. They are named Dan and Jenny. And it's a vertex object I have explained before. Also, you can use a curl to curl the endpoints that associated with this query. So I'm temporarily quit the GCQ, and I can invoke this curl commands. And the format is just your server address, 9,000, and query, and the graph name, and then the query name. And then after the question mark, you can put key value parameters. So I put Tom, then it returns Tom. So I can try Jenny. Then it returns the first neighbor of Jenny. So I'm returning back to GCQ. I just type GCQ.